And so, as I said, this is the last lecture of this course. And in this lecture, we are going to talk about instance segmentation. And the idea will be, we will briefly talk about what this problem is and how this is different from other segmentation problems we have studied so far. We have briefly talked about those things earlier as well. And basically, like, two important topics for today will be, the first will be like how we extend like object detection to instance segmentation. That's, I think, very, very interesting way to solve this problem. The second aspect is you have studied proposals, right? How we can improve proposals. So if you remember, like when we were talking about object detection, there were some issues the way the ROI pooling was being performed. There was some loss of information, and there was some additional contextual information which was being utilized, which we didn't need. So we'll try to address some of those issues here when we do this instance segmentation. All right, so let's start. Now, instance segmentation, it's different from semantic segmentation, which was the topic of last lecture. And you have seen this image before as well. So given this image, semantic segmentation will be, for each pixel, you have to say which semantic category or which object categories that pixel belongs to, whether it's a table, it's a wall, it's a chair. And it will look something like this, the output result on the right. Okay, so it just says, okay, which semantic category each pixel belongs to. For example, if a red is for chair, you will just mark all the pixels red which belongs to chair. Similarly, if a pixel belongs to table, you will just mark all the pixels orange. Now, today we are going to see like instance segmentation, and like the high level idea is similar. You have to still say which semantic category each pixel belongs to. But there is one additional task which differentiates instance segmentation from semantic segmentation. Here you also have to separate different instances of the same category. For example, if you have to do semantic segmentation of chairs, but if you have two different instances of that chair, your algorithm will have to say that, okay, this is chair number 1 and this is chair number 2, and these two are different instances. Okay. Other than that, the problem is almost same as semantic segmentation. Now, let's see like what are the different ways which can be used to solve this instance segmentation problem. Now, the result on the center for this image is for semantic segmentation, where blue is for television, and this pinkish color is for like people, and this is for table. So now you can see that even though we have like these fine boundaries, right, where people are present, but then we don't know like what are the separating boundaries between these two individuals or these two individuals. Okay, so that part was missing in semantic segmentation. So we need instance segmentation where we'll have to separate or create these boundaries as well. Even though these two regions are like the same semantic category, but still we'll have to separate those two. Okay, so this output on the right is from instance segmentation. Now, one simple way to solve this problem of instance segmentation could be you can take the image and just do object detection. And object detection gives you this kind of bounding box around each object instance, right? So it will tell you like how many people are present here. It will give you like TV monitor as well, and many other objects as well. And since your bounding box is surrounding like each individual separately or each instance separately, then you have like some rough idea about which pixels actually belong to which instance. And what you can do is you can kind of use this information to separate two different instances of the same category. All right. So you can draw bounding boxes around here, and then you can use maybe some distinction between those two. But again, the challenge will be that boundary is not going to be very, very fine. It's not going to be like this. You'll have to use some kind of heuristics. It might be some straight line, okay? Or you can use maybe some other heuristics, like what kind of shape you have in the other regions, and maybe some continuity on that surface. So it's not going to be perfect like this, but still you will be able to tell like how many different instances are present and some rough boundary of those.